Hi everyone, this is part 3 of developing LangSmith-like observability solutions for LangGraph workflows. In part 2, I explained how to develop a UI around our observability layer, where the output looks like this. We have the input, we get the final response, we have some run summary, which gives the overall summary statistics, and then we have trace of each node that ran in that for that flow. Okay, so it will give information about tokens, seconds, it will give all the information that we need within the node also. But the problem with this is that we are not able to save the information as and when we are asking more questions. Okay, so this is the whole purpose of having observability layer, that whatever questions we are asking, whatever inputs we are uh, trying to run through this flow, we want to record that for future reference or to check later what happened in the past for that particular question. For that reason, in this part, I will explain how to attach a database to this solution, and then how we can record every solution and the observability output of every question in that database. And then we can retrieve also later from that database. So I will show you how the new application will look like, and then we will see how it can be developed. So this is the second part of the solution that I've developed, which has a database integrated. Here it will show all the list of previous runs. My database is blank right now, but when I start asking questions, you will see that it will keep getting recorded and we can refer later also. So let's ask a question. So when I press, so here the output looks exactly the same like we saw in part 2, but you can see that the run is recorded in the database. Now, if I ask another question, then you would see that the previous run was also there. So this one is the current run where this is being tracked based on the ID, and this is the output. This is the trace, and these are the summary. Everything is there. But if I click on the previous one, that also will again get loaded, and then we can go back to the details again. So let me ask another one here. See, so all three are there. And then whenever we want, we can go back to any one of them. And even if we refresh the application, then also everything we will still see. And we can go to any one of them. So let's see how to develop this on top of what we developed in part 2. So if you have not gone through part 1 and part 2, so part 1 explains that how to build the core logic of this observability layer, and part 2 explains how to build a UI around that observability. And in part 3, we will see how to attach database and then record and retrieve all the information from the database. So let's go to the code now. So I have added another file in the same root location, which is observability.db. So I will show you all the methods that I've defined here. So here for demonstration purpose, we are using simply SQLite 3, which creates a local database file of name that we give. In my case, it will be observability.db. So whatever recording happens, it will all be recorded in this file only. So we don't have to attach it to any external database, but for production use, we can attach it to any database we want. Okay, so I'll show you what all methods I have defined here and what all they do. So first is initdb. So it will run only when the database file doesn't exist already. It will run at that time only. So here what I'm doing is that I'm trying to divide the output that we have into two parts. Okay, so one is this table, the runs table, and second is a nodes table. So if you see the output, so I will show you how the output looks like. So yeah, so this is the output that is generated by my observability layer from the core logic, which has this JSON structure, which is nested in nature. It has some information at the root level, like run ID, start time, total tokens, total latency errors. And then it has a nested uh, JSON also, which is saved in the nodes field. So this is a list of JSONs where for each node we have a separate JSON, okay, or a dictionary. So what we will do, we will create two tables. One will be run table, which will save all the root level information. And second will be nodes table, which will save entry of each run in a separate row. And then later we will extract information based on the run ID. We will extract information from both the tables and join them together into a single JSON like this. So, okay, so this will be the most efficient way of handling this. So first table is runs table, where all this information will be saved. Run ID, user query, final response, start time, all these root level information. And then the run nodes table, where inside the node, whatever information we are saving, that will be saved. And then this will be the foreign key. The run ID will be foreign key for this table. So for each run ID, there will be unique record in this table, but for each run ID, there will always be multiple records in this table. Okay, so this method will simply create these tables if they don't already exist. So whenever we do init underscore db, it will check create index if not so create table if not exists, create table if not exists. Okay, so if it does not exist, then only it will be created. And then for making things more efficient, we are indexing these columns also. So tomorrow if we want to try to get more information out of these tables, then indexing certain columns make things faster. Okay, so this is first method. Second method is save run. So whenever an output is generated in form of a JSON, we will always call this save run method, where we will provide all this information, okay, to this. And then from here, it will simply save this information based on run ID into both of these tables. One is this table, one is this table, and second is this table nodes. Okay, so this is save. Now get run. So whenever we click, for example, we are clicking here, so this will call get run method. Okay, so get run, simply it will take the run ID as input, and then based on that run ID, it will extract data from both the tables, run table and node table, and then it will combine it. So here it is combining all the information. So yeah, so this will have the information in list format. So yeah, so here we are starting it from, this is the root level JSON, and in run data JSON only, we are adding all this information in the nodes field. Okay, so simply this will get the get run. And then another thing that we always have to do when we open the application is list run IDs. So which you can see here. So whenever we open the application, so list run IDs will always run, where it will only extract the list of unique run IDs from only one table, which is runs. We don't need the nodes table here because we only care about the run IDs. And from those run IDs, we will get the information, what is the question also, and what was the timestamp when this question was asked. Okay, so this will be populated based on this method. So very simple, very straightforward, that how we can interact with the database. So this file we will import into our app.py file. So I have created a new version of app.py, naming app_db.py, so that we can retain the previous version also. Okay, so here the changes that I've made are these. So if we come to this method, route, this root method, which will accept both get and post. So if you see here, whenever I'm pressing send button, it is sending a post request. But whenever I'm clicking on this, it is sending a get request, where the run ID has to be extracted from the get. Okay, so what will happen is that whenever user presses the send button, then the post method will be called. We will get the message. Here I'm just printing for testing purpose. Now collector.reset, that I've already explained in part 2. Now we will send the message, the user input, to this graph, okay, which we have already imported. After run, we will run collector.build, which will save all the information in trace JSON. We add the user query to this JSON, as well as the final response to this JSON. This is for the reason to show it like this. So if I click here, so user input and final response, we can show it here. Okay, for that purpose, I had to add this. Then what we will do, instead of sending this trace JSON to the UI, we will save it into the DB using save run. So if in the save run method, if you see, it accepts all these fields. Okay, but we have a dictionary. So what we will do, we will simply convert this dictionary into list of fields. Okay, fields and values. So simply save run will save all the information for that particular run into the database. Then we will get the run ID. And then what we will do, we will from here post, we will call the redirect URL to get URL. Okay, so we will simply send the request to this URL where the run ID that we have just generated. We will call this URL, and then what this URL will do is this. So it is a get request. It will get the run ID, and now it will hit the database get run method. Based on that run ID, it will get all the JSON, which is already formulated as a nested JSON. If you see here, get run, it has extracted all the information from both the tables, and then it has created the JSON in the desired format for us, and then it is simply sending that data. Okay. So the JSON is created now. Now we will simply render this template into this URL where runs will be. Okay, so runs will populate this. So always list run IDs will always run. If this is not available, like for example, if I'm only sending like this, then this information will not be available. Uh, this information will not be available. Then the trace JSON will not be created. Okay, so trace JSON will be null. Okay, but still the list run ID will always run, which will always populate this information. Okay, so now this might not be the most efficient way of doing this, but since the UI part, I take ChatGPT's help to develop the UI, so this is what it suggested. But if you have any suggestions on how to optimize this further, please let me know in comment section. So this is the backend code, and UI code, as I've already told that it is developed by ChatGPT. So this is what it is. So that's all for this video. So here we saw that how to connect database and save everything that we have generated using observability layer and then retrieve it later. Okay, so that's all for this video. Thank you for watching. Bye.